Good evening, everyone. Let us start this session with a moment of silent prayer. Thank you. Let us start the session. It is my privilege to welcome you to the day 4 of the Faculty Development Program from Models to Manuscripts Structural Equation Modeling for High Impact Publications, organized by the Department of Professional Accounting and Finance under the School of Commerce, Accounting and Finance, Kustu Jayanti University, Bengaluru. Over the past 3 days, the session have offered profound insights into the basics of structural equation modeling and AMOS software in scholarly writings. This evening, we are honored to continue this academic engagement under the expert guidance of our distinguished resource person, Dr. Ramesh Babuti. We appreciate your continued participation and look forward to another session of meaningful learning and intellectual enrichment. Over to you, sir.
Thank you, ma'am. Hope the screen is visible, ma'am.
Zoom, I think you have shared Zoom. Yes, sir. Yes, it's visible.
Yes. Yeah. So today we will be starting with how to conduct CFA in AMOS. So for this session, I hope you all received the data file. Am I right, ma'am?
Yes,
Yeah.
sir. We have
Yeah.
mailed.
Yeah. So today I'll be using the data which are available online. That particular data belongs to this Maslack burnout inventory article. So we test our hypothesis today bearing on this particular tool, which was developed initially in 1981 and modified in 1986. So which is designed to measure 3 dimensions of burnout. There are total 22 items. Uh, and there are 9 items which attempt to measure the emotional exhaustion, and depersonalization 5 items, and the reduced personal accomplishment 8 items. So this is the reference. I request all of you, after this session, you read this original article, which was published in 1994. So the data which are taken today as part of this particular paper, which is available freely. So when you read it, there are 4 models they have done it. I try my level best to complete the models because the modification indices and all uh, to complete, because today as the last date for our structural equation modeling session, I would like to give at the end of the day a meaningful understanding about the how to conduct a confirmatory factor analysis, and modify modifications, respecifying the model, and also what are the things that we are supposed to follow when we are actually planning to publish using structural equation modeling. Is that what is the output that is most important for us? All right. So here, if you read this article later, you will understand that the purpose of this study is threefold, right? So they mentioned that in this article, they wanted to test the factorial validity of this Maslach burner inventory separately for both male as well as the female elementary and secondary teachers. And also, the other purpose was this original article to cross-validate findings across a second independent sample for each of these populations. Third, to test for invariant factorial measurement and structure across gender for each of the 2 teaching panels. So here, for the purpose of this today demonstration, I'm only using the factorial validity of the MBI for a sample of elementary male teachers. So the data which I've shared earlier, so belongs to these elementary school male teachers. The total sample size is 372. So I'm using this data, not all the other purposes that the original paper had. So here, so based on this article, the CFA model of this MBI structure hypothesizes a priori that responses to the MBI can be explained by three factors, which is emotional exhaustion, depersonalization, and this personal achievement. If I'm not wrong, yeah, personal accomplishment. Sorry. So then they also hypothesizes a priori each item has a non-zero loading on the burnout factor it was designed to measure and zero loadings to on all other factors. The third hypothesis is that the three factors are correlated, and the last one, the error uniqueness terms associated with the item measurements are uncorrelated. So this is the model which we are going to draw now, because this is the hypothesizing model one for factorial structure of the Maslach burnout inventory. Imagine, as I mentioned earlier, there are 22 items as based on the items which belongs to these latent factors. So emotional exhaustion, they said that factor one, and depersonalization factor two, and the personal accomplishment factor three. Now, looking at this picture, now let us turn to the Amos, how to draw this particular model. So actually, when you are trying to draw initially, it takes a lot of time. Even for me, it took almost 15 to 20 minutes, because every time you are trying to draw this model, it may not appear as good as this picture. All right. So make sure that you keep practicing it. You keep, use trial and error method. Like, if you don't like it, and, go back and, start doing it. So definitely you will have this perfect model. All right. So here, because it takes a lot of time, what I did was I actually drawn this particular model. I'll explain how you're supposed to draw. The first thing is, so I'm using this. After some time, I'll close this. If at all you wanted to draw initially, I know I have already demonstrated how to draw path analysis, but I just wanted to take another uh, new with template. So just to showcase how you can draw. So for example, here there are three latent variables we have. There are two ways that you can actually draw. The first thing is, either you can click on this draw unobserved variable and, draw this one latent variable, right? Then you can also go back, click on this duplicate, and make sure that you duplicate these three latent variables. Then after that, based on the number of factors, you can click on this particular icon called draw a latent variable or add an indicator to a latent variable. Because I already draw a latent variable, I can simply draw this latent variable. So, sorry, I can simply draw an indicator variable, meaning a manifested variable. So I can click one time here, the one manifested variable or observed variable. I can click multiple times, because I said there are 9 items in this particular emotional exhaustion. I can uh, click 9 times, 5, 6, 7, 8, 9. Right? Similarly, I can click here 5 times, because there are 5 items, in which the last one, personal accomplishment, 8 items. I can click on 8 times, right? 5, 6, 7, 8. So now, upon, deselecting this, so I just wanted to, replace it properly. In this case, what I can do is, I can click on this rotate the indicators of a latent variable. So what I can do here is, I can click here. When I click on rotate button, it will come like this, right? Whichever way I want, I can rotate. So let us use this particular way, your right side. The similarly, you can also do this, all right, and do this. So likewise, you are to, when you have given enough space between these latent factors, it come no, perfectly like this, all right. So then once you clicked it, then you can unclick rotate and click on right click object properties, that you can name whatever variable name like emotional exhaustion, depersonalization, and personal accomplishment. Then you also need to type object properties even in the measured variable. All right. So the measured variable, the way you have entered your data in your SPSS, the similarly you have to enter. Imagine you have used item one, I capital TEM small and number one with space. Then similarly you have to enter here. Imagine if you are entered data in a different manner and you are trying to use it, it says that it will say there is an error because the data directly takes it. The way you have entered in your Excel, sorry, your SPSS, then you should enter the data here. So when you enter all these item 1, item 2, item 3 in this measured, rectangular, then you keep adding the error items like, ERR1 or E1, error 1, error 2, error 3, depends on whichever number item you are giving here. So likewise, you can draw this particular picture, right? I don't want to save this because I already uh, draw the picture. All right. So 1 second, let me, yeah, yeah. So this is the model I had drawn. All right. I have entered like item one, item two, item three, item four. This is how the data has been entered. You can check the data which I shared, the MBI data. So then after entering, I made sure that the error, because this is item number one, I mentioned E1, which is error one. So because this is item number 8, I mentioned E8 because there are 9 items. Item 1 to item 20 belongs to emotional exhaustion based on my theoretical underpinnings. And the depersonalization, item number 5 to item number 22, there are 5 items. And personal accomplishment, factor 3, as per my theory, there are 8 items, item 4 to items. Then once I draw these things, I also need to draw this uh, the correlations or the covariances between the latent factors. So the personal accomplishment to depersonalization, depersonalization to emotional exhaustion, and emotional exhaustion to personal accomplishment. So this is how you draw. Once you draw, you know how to run this because I have explained very clearly when we did the path analysis. You can click here, right? Click on this particular icon called data. Then you can select the file name wherever your data file is there, select it and open it, and automatically data will be taken. All right. So here, because I have already given, so once you give this, you can go to this analysis properties. All right. So once you go this analysis properties, so you have to, yeah, you have to estimate the maximum likelihood method or confirmatory factor analysis. That what is most important for us is this, output. Under the output, make sure that you select standardized estimates and modification indices. By default, certain almost will have 4, 2, 3. Make sure that you enter threshold for modification indices 10. And also you can check for the test for normality outliers. This much is enough in the initially in order to see that how the model is coming. All right. Then you click here. Then you can go to the calculate estimates. So here you see this is error has come now because there is a gap. See, you can read the variable name depersonalization F2 is invalid because it contains an invalid character. So then what I can do here is I click object properties, right? Then I see, I make sure that there is no gap, all right? And when I click here and try to click once again it says that personal accomplishment because it contains an invalid character, and click here, object properties. If I had given any gap, unnecessary gap between these while entering, it will not take it. So F3, then close it, then again try to click here. Now it is running, right? So you can see these unstandardized coefficients for the model 1 hypothesized model, and you can click here the standardized, and this is unstandardized, these are the standardized values. But what is most important for us is, like, the view text option. The what is the fit indices has given the uh, text message. So then when you click on this, the first thing is you will see this notes per model, like in a default model. You can see that the chi-square he found 693.849, and their degrees of freedom 206 and probability level 0. You can see that the number of distinct sample movements 253 and the degrees of freedom is 206. Now let us try to understand this output from this hypothesized model, because there are a number of things you need to understand, and I would like to take you through. The lot of content is there, so I made myself sure that I will not forget anything. So I try to give the maximum information in these slides. So for example, in the reviewing this notes per model, we see that the estimation of hypothesized model resulted in an overall chi-square value is 693 with the 206 degrees of freedom, and p-value is 0.000. Of the important notation that the minimum was achieved, meaning what is this minimum was achieved? You can see, all right, you can see this particular, the minimum was achieved. This is what Amos reached a local minimum. So what does this mean? The minimum achieved meaning. So this statement indicates that Amos was successful in estimating all model parameters, thereby resulting in a convergent solution. All right, that is what the meaning of minimum was achieved. So here, if on the other hand, the program had not been able to achieve this goal, if you see in your output something else other than minimum was achieved, it would mean that it was unsuccessful in being able to reach this minimum discrepancy value as defined by the program. Like, you and I will not define, as Amos defines this, what is the minimum discrepancy value based on the data in its comparison of the sample covariance and restricted covariance matrices. We are nothing to do with manually here. The Amos itself will take care based on the data set you have. So typically, an outcome of this sort results from incorrectly specified models, or in which there are linear dependencies among the certain variables. So whenever you see this, like, minimum was achieved, which means that there are incorrect specified models or data in which you can see that there are linear dependencies among certain variables, among all these 22 variables. That is what you have to understand when you have this minimum was achieved. So then, once you found that, once you have identified there are some linear dependencies, the other thing we need to look for the multivariate outliers, because you are all aware that as a researchers or faculty, outliers basically represent scores that are substantially deviant from all others in a particular set of data. So here, a univariate outlier has an extreme score on a single variable, whereas a multivariate outlier has an extreme scores on two or more variables. Here you can see there are 22 variables are there, which is manifested variables, observed variables, which means that the moment when I say there is a multivariate outlier, which means there are multiple outlier scores in these manifested variables. So a common approach to the detection of this multivariate outliers is the computation of squared Mahalanobis distance called D2, sorry, it's D square for each case. So if you wanted to understand this, you are supposed to do this D square analysis. The D square analysis or the squared Mahalanobis distance, if you would have done earlier any time, regression analysis in SPSS, you will know, like, when we are doing simultaneous multiple linear regression or any other multiple linear regression, so other than simple linear regression, by default, Mahalanobis or Cook's values is mandatory for us to see whether are there any multivariate outliers are there. So, but here what we are doing is the squared Mahalanobis distance. So it basically measures the distance in standard deviation units between a set of scores for one case and the sample means of all variables, which means centroids. So typically an outlier will have a d square value that stands distinctively apart from all other d square values. When you see a d square value which is distinctively apart from other values, you can say that there is a outlier, multivariate outlier. Looking back at the observations farthest from the centroid entered on the line below the assessment of normality. So where you can see here, like, you go back, remember on the model summary, you see this observations farthest from the centroid, Mahalanobis distance. You can click here, right? So it will give you the Mahalanobis value, all right? So these are the Mahalanobis values. So what basically tells that clicking on these lines basically provides us with the information needed for determining whether are there any presence of multivariate outliers. From a review of these files, we can conclude that there is a minimal evidence of serious multivariate outliers in our data, uh, because a critical important assumption in the conduct of some analysis is that data are considered as multivariate normal. If the data are multivariate non-normal, there will be an issue. So by just looking at this particular issue, it has not highlighted any specific thing. So you can see yourself and make sure that it appears normal. There are not much deviations. So then you can go back and while interpreting, before any analysis of data are undertaken, it is important to check that this criterion has been met. How do we met? If I scroll down, I think I know that everything appears to normal, right? But there are things that I need to look into it, right? So in that case, what I can do here is prerequisite to this assessment of multivariate normality is the need to check for univariate normality is a necessary condition for multivariate normality, right? Before you check the multivariate, you need to check the univariate normality. Thus now, look at the analysis properties dialog box, C for an assessment of normality. Statistical research has shown that, all right, uh, has shown that whereas skewness tends to impact the test means, kurtosis severely affects the test variances and the covariances. Given that the sum is based on the analysis of covariance, we are not bothered about the skewness values because skewness is basically impacts the mean values. Like, but when we are running with the multivariate statistics, where we need to focus more on the this kurtosis value. So given this sum is based on this analysis of covariance structures, evidence of kurtosis is always of concern as it is known to be exceptionally detrimental in some analysis in order to identify whether you have a normal data or a non-normal data. So here in this case, with this in mind, let us first look at the univariate statistics. We focus only on the last two columns of the assessment of normality, where we find the univariate kurtosis value and the critical ratio values. Where you can find here, you can go back to the you can go back here, click on the analysis properties. So what you need to do is you need to see test for normality. Yes, of course I have given. So Yeah. So look at this data. So what we are interested in this last two columns, which is kurtosis values and the critical ratio values. If you look at this data, as I mentioned, there is the lowest positive value is 0.007, right? As you can see here, you see the positive values range from uh, 0.07 to 5.10, and there are negative values from minus 0.597 to minus 1.156. This is where you can see these values, kurtosis value. This is 0.07, the lowest positive value. Then you have this highest positive value, 5.100, and whereas the lowest minus value you have minus 1.100, so 1.156. So after looking at this particular univariate statistics normality of the Z values or the critical ratio values for all your 22 like MBA items, the standardized kurtosis index in a normal distribution, normally the standardized kurtosis index, what you call as a beta 2, in a normal distribution has a value of 3, with larger the values representing positive kurtosis and the lesser the values representing a negative kurtosis value. So the data revealed no item is substantially kurtotic, though there are slightly different values more than 3, regardless of whether the distribution of observed variables is univariate normal. The multivariate distribution can still be a multivariate non-normal. So what does it mean here? When you look at this particular data, you see the kurtosis values, right? Not many values gone outside this plus or minus 3. So one particular item 17 5.10, then you can see this item number 7 3.80 3.66, and item number 15 4.27. So most of the univariate data items looks normal, but what is most important for us, because when you are doing some analysis, we need to look into the multivariate kurtosis value and the critical ratio value. Look at this here, the critical ratio value is almost 37.978. It obviously indicates that there is a multivariate non-normal data, right? So here, does now look at this index of multivariate kurtosis and its critical ratio. As for the statistician Bentler has suggested that in practice, when we are trying to estimate the normalized data, anything greater than zero point 0.5 are an indicator of data that the data are uh, multivariate non-normally distributed. In our data, you can see that G statistics is almost 37.978, which is highly suggestive of there is a multivariate non-normality in the sample. So this is the number I'm actually referring to it. This is 37.978 as a critical ratio value. So once we found that there is, the problem with our data, how do we address the presence of non-normal data? That's the issue now. So remember when continuous data, because this particular tool has a 7-point scale, Likert scale, the lowest possible response for each item is 0, and the highest possible response for each item is 6, which is a continuous data. When continuous data reveal evidence of there is a multivariate kurtosis, interpretations based on the usual maximum likelihood estimation may be problematic. That is what many statisticians or researchers are noting it. And thus, an alternative method of this estimation is likely more appropriate. What is that alternatives that more appropriate is? The best alternative when you find this multivariate kurtosis reveals, we can do this asymptomatic distribution tree, that we call it as a ADF estimation. However, there is a limitation for us to use this particular thing. One thing is, unless the sample sizes are approximately large, meaning if you have a data more than 1000 to 5000, in between 1000 to 5000 cases or anything more than that, then only the ADF estimator of uh, unless sample sizes are very large, the ADF estimator performs very poorly. Meaning, if you now here in our case, we had only 372 samples. We cannot try doing this because there is no point in doing this, because several researchers are already mentioned that there is no point of doing this because it gives a poor indication and it are severely distorted and estimated values and the standard errors. So this was mentioned by West et al. And Karan et al. And other several statisticians also have warned us not to do this ADF estimator if you do not have more data or more than 1000 data. And there is also other researchers, statisticians line suggested that when you have this issue, there should be a bootstrapping approach in testing of models based on the non-normal data. Because since we have only 372 sample approximately, and since we don't have this, we can't do ADF estimator. It's better we can do the bootstrapping approach, all right, to address this non-normal data issues. So several researchers have suggested use of this Bolenstein bootstrapping procedure to addressing the issue of non-normal data. However, several authors have mentioned that, and all of us should note this important point, that this Bolenstein bootstrapping procedure is not designed to test basically for the normality. Rather, it tests for the correctness of a hypothesized model without assuming the normality. So which means that this particular data doesn't assume normality when we are using this Bolenstein. But here, since there are several researchers that actively saying that the Bolenstein procedure gives some kind of an indication, let us once again test this hypothesizer model of the MBI using the same specification. However, we now request the Bolenstein bootstrap procedure. How do we do that now? Here, you go here and click on this analysis properties. And already you have given output standardized estimates, modification indices, and test for normality. Now you click on the bootstrap approach. Then you say the perform bootstrap. So because the data expect us to have more than 1000, let me enter 1000 bootstraps. You can also enter as many as possible. And also I wanted to bootstrap for this maximum likelihood method. And finally, I need to select this Bolenstein bootstrap approach. All right. When I click these things, when I close this, then I can see when I perform this particular calculate estimates. So now I can see that there is a bootstrap method. So I can see here under the modification indices, summary of the bootstrap iterations, the Bolenstein's bootstrap value. So what is this says? You read this. The model fit better in 1000 bootstrap samples. It fit about equally well in zero bootstrap samples. It fit worse or failed to fit in zero bootstrap samples. So testing the null hypothesis that the model is correct, the Bolenstein bootstrap P is equal to 0.001. Now, what does it mean? When you have this particular, results, the result shows that the model fit better in 1000 bootstrap samples than it did in the original sample. That is what is basically here it is talking about. The model fit better in 1000 bootstrap samples, correct? So this is what the meaning. The result shows that the model fit better in 1000 bootstrap samples than it did in the original sample. In terms of the probability, if you wanted to look at in the probability level, the results imply that the likelihood of this happening by chance, if the specified model holds in the real population, is equivalent to 1 by 1000. Because imagine you have collected data 1000 times, because it has bootstrap 1000 times. Your data is 1001 number if you are giving in a serial number. So the possibility of the probability is only 0.0010. Thus, we can reject the null hypothesis that the specified model is correct in the real population with probability value equivalent to 0.001, right? So from a review of these bootstrapping results, it is clear that bootstrapping procedure did not actually yield no particular benefits in testing for the factorial validity of the MBI based on this non-normally distributed data. Because we are only saying that when 10,000 times it bootstrapped, it did well, but not in the original data. So it merely what this basically did it merely reassessed the model fit using a more robust method, because using this Wallenstein method, right? So here, after looking at this, when we understand that it has not done any added any value, now you need to look into the goodness of fit summary or a model evaluation. So in order to look at this model evaluation, you can go to the model fit, sorry, estimates, where is this model summary? Parameter summary, yeah, model fit, right? So when you look at this model fit, so what we need to look into it, the goodness of fit summary. In reviewing these fit indices criteria in terms of their optimal values, we can see that there is an ill-fitting model. For example, CFI value is 0.848. Why it is ill-fitting model? Where is the CFI value? This one, right? Baseline comparisons. Remember yesterday when I was explaining about the path analysis, I said that, all these values should be more than 0.90, right? Or some researchers even says that, higher the value 9.95. In the earlier example, yesterday's example, we have seen CFA value almost near 0.994, right? Something like that. So here you can see that the model is ill-fitted model because the value is less than. None of the values, even NFI, RFI, TLI, or CFI has gone more than 9 value, 0.9 value. So it indicates that there is, ill-fitting model. It shows that it is extremely poor fit of this particular model, whatever we try. Thus, it is apparent that some modification specification is needed in order to identify a model that better represents the sample data. To assist us in pinpointing a possible areas of misfit, let us examine the modification indices, because we wanted to know, we know by looking at the CFI values that the model fit is not good, but how do we know that where this model fit or, the problematic areas are there? In order to know that, we need to look at the modification indices. So where is this modification indices? You can see, right? You can click on this particular, this one, modification indices. When you look at it, there are covariance matrices. There are also regression weights, right? When you look at this, you can see that there are errors or values between error 12 to the emotional exhaustion, and also error 13 to personal accomplishment, factor 3, and E1 to personal accomplishment. Even if when you look at the regression rates, you can see item 12 loading into the emotional exhaustion. But actually, when you look into the original data, right, we did not loaded like theoretically under the emotional exhaustion. I think uh, I need to show this picture. All right. If you look at the initial, item 12 is here under the personal accomplishment. but I think it is loading or cross loading in the emotional exhaustion, right? That is where that is what the meaning. Let me go back. We'll see once again. So here, when you look at this particular data set, like regression weights, you can see that there are problematic covariances between item number 12 and emotional exhaustion, item number 13 to personal accomplishment, item number 2 to personal accomplishment, item number 1 to personal accomplishment, all right? So what does it mean here? A large mi values argues that because all those values you can see the large values, say 33.856, even you can see E1 to E2 74.80, and this critical ratio is 0.557. So all those large mi values and path charges indicates that there is something wrong in your data set. In reviewing this, for example, you will see suggested regression paths between two observed variables, which is item number 4 to item number 7, and suggested covariances between error terms and factors between error 12 and emotional exhaustion, neither of which makes any substantive sense to us, because error 12 and emotional exhaustion, because error 12 is related to item number 12. That item number 12, as basically based on the theory, it is supposed to come under the personal accomplishment. So when you look at these things, neither of which makes any substantive sense for us to understand. So given this meaninglessness of these modification indices, we focus solely on the those representing cross loadings and error covariances. So what does it mean? Turning first to the MIs related to the covariances, we see very clear evidence of misspecification associated with the pairing of error terms associated with items 1 and 2. If you go back and see error 2 to error 1 here in this particular, this one, error 1 and error 2, you have a MI modification indices value of 74.802, right? So this is what it says. With item 1 and item 2, error 2, error 1, the modification indices value almost 74.82, and those associated with the items 6 to 16, which means error 6 to error 16 to error 6, right? Error 16 to error 6, this particular value is also having a large value. It's almost 88.728. So I think these are the two covariances you can see as having a larger values, 88 and 74. So in this case, there are few additionally, although there are few additionally quite large MI values, where you can see that I think some of the values are having 34, 31, all right? Uh, yeah, 34, 31. But these are the two major problematic uh, covariations. Although these additional quite large MIS values, these two stand apart in that there are substantially larger than the other values, other covariances. So these measurement error covariances basically represent there are systematic error in terms of responses, and they may derive from the characteristics of specific to either items, which means that the items have not been written properly, or the way the respondents have responded. For example, imagine if you think that your respondent have got certain errors based on the respondent characteristics, such as, like, whenever you give any survey questions, there is a tendency that you can see, you can observe certain individuals, yes, say a saying or nay saying. Meaning, when you have a 5-point Likert scale, where you have one strongly disagree and five strongly agree, there are people put all the extreme options, like strongly agree, strongly agree, strongly agree. That is what we say a saying, or everybody disagree with everything, like majority of the items strongly disagree, strongly disagree. So this is what the reflect bias, which means that we do not know whether the person has read the questions and understand what is it asking, How can any person say that everything in a questionnaire can be given into a saying or an essay? Or also sometimes based on a particular psychological constructs, there is also social desirability among our participants, which means that because all of us are wanted to be thrown good light of on us, we tend to give a false, responses where we will be shown that we are too good, right? So which means that based on the what society expect me to do it, I may tend to give these responses. So this systematic error, as I mentioned, either may come from these item characteristics or the respondent characteristics, right? Another type of method is also method effect, which also can trigger error covariances, is a high degree of overlap in the item category, which means that when you are written in items, like the author would have written the redundancy items, right, to a particular item. For example, if you look at these original items of this MBI tool, so there are two items where item 16 asks whether working with people directly puts too much stress on the respondent, while item 6 asks whether working with people all day puts a real strain on him or her. Like, you see that the meaning is the same, right? But like, the respondents may have considered this as a redundancy item. It looks like worded words are very different, but essentially you are asking the same question, right? So when you are actually making tools or developing tools, we need to see that are there any issues with these redundancy issues. A review of this MIs for the regression weights or the factor loadings reveals there are four parameters indicative of cross loadings. So where you can see that item 12 to emotional exhaustion, item 1 to personal accomplishment. So for example, here, what I'm describing here, I'm looking at the regression weights under the modification indices. You can see that item 12 to emotional exhaustion, item 13 to personal accomplishment, item 2 to personal accomplishment, item 1 to personal accomplishment. So these four items, all right, you can see item 12 to emotional exhaustion, item 1 to personal, item 2 to personal, item 13 to personal. Now, let us draw our attention to the one with the highest value of MI. So among these three, four, like, you can see there is one particular MI which is having 33.856, which is the item number 12 to emotional exhaustion. As you have seen earlier, this item number 12 was actually given in the personal accomplishment. But here this modification indices shows that there are 33.856 modification indices value. So this parameter represents the cross loading of item 12 on the emotional exhaustion factor. It stands apart from the three other possible cross-loading misspecifications. Though these three are, have misspecifications, but the values are not that bigger. So for example, here you see personal item number 13 to personal accomplishment 10.418, here 10.507, here 23.657. When you compare all those four items, I think item number 12 has got huge difference or highest MI value, right? So it definitely shows that there is a misspecification of this particular item in the your hypothesized dimension. So such misspecification means that the item 12, in addition to measuring the personal accomplishment, also measures the emotional exhaustion. That is what you need to understand. So this is when you are actually done the exploratory factor analysis using this data, you would have already found that probably this particular one item is loading on the two different factors with small difference in the factor loading, right? So this is what the meaning of this particular high modification indices. Now, once you have identified this, we are supposed to do a modification in, post hoc analysis. Excuse me. provided with the information related both to model fit and the possible areas of model specification. Now we may wish to consider respecifying the original hypothesized model, because we understood that the model is not fitting well, because the values of all fit indices are lower than 0.90, and there are also error variance issues are there. We also seen that a particular items are not loading onto single factor. There are additional dimensions this particular item is loading. So having determined that inadequate fit of the hypothesized model to the sample data, and also at least there are two misspecified parameters in the model, it seems both reasonable and also logical that we now move on to the exploratory mode and attempt to modify this model in a sound and more reasonable manner. So the based on the understandings we had. So now what we are going to do is we are gonna modify the model. So how do we modify the model? Because the respecification of the hypothesized model of MBA structure involves the addition of freely estimated parameters to the model. However, because the estimation of MIs in AMOS is based on a univariate approach, as I already mentioned several times, it is critical that we add only one parameter at a time to the model. Though we have identified there are 3 or 4 problems based on the initial hypothesized model, you cannot make the model, respecify the model, all the changes in a one single occasion. So you need to do it one at a time and see that, are there any changes? So thus in building model 2, it seems most reasonable to proceed first in adding to the model the error covariances having the largest MI. All right. So what was the largest MI we had? As we have seen in the modification indices, this parameter represents the error terms for item number 6 to 16, and according to this parameter, change statistics should result in a parameter estimated value approximately 0.714. So if you see this particular 6 to 16, all right, where is this? Yeah, 6 to 16, you see modification indices value is 88.728, and you have the this change is 0.714. So this is what we are actually talking about. This parameter represents and should result in a parameter estimated value approximately 0.74. Hence we try to draw, we draw your attention to them, to the item number 6 to 16, uh, as they reflect a problematic link. More realistically, this issue is addressed through the specification of error of an error covariance. Meaning, now turning to the Amos graphics, we modify the initially hypothesized model by adding to a covariance between these items 16 and 2. How do we do that? This is how we try to change the model. Remember this particular items. Earlier model 1, hypothesized model, we do not have a covariance between these items 6 and 16. So now we need to add this as a model 2 and test it. So here I'm going back to the Amos, right? And I just wanted to see that, can I draw anything like, covariance between these things. So in this case, I'll just go to the analysis properties. Not analysis, I need to go to the, yeah. Yeah. So what I need to do is I need to change the covariance. So I'll click here. I need to find the covariance matrices between item number 6 and 16. So I select this item number 60. Why am I not? Yeah. So I think there is some mistake somewhere I did. I think so. Error items I have given this side. So I was unable to select it. What we are supposed to do this, we need to select this covariance matrices and add a covariance matrix between your item number 6 to item number 16. So this will add, will become the model 2 like this. All right. So then once you do this, and there will be one after adding this particular value, I think I need to redraw in order to do that, because I have put everything error values this side, so I'm unable to select. So that could be the reason. So in this case, once you add the covariance value, the double-headed arrow, then you can click on the calculate estimates. When you click on this calculate estimates, then one more AMOS output will come for the model. Right here, again, we have seen so much of explanation. You can straight away here, you can look into the, once you are doing it, you can see that whether is there any change. We can note that the decrease, whether the values decrease. I think I have done this. Just give me 1 second. On the desktop, might have given. I just wanted to show how the values would change. Yeah, fine. Anyhow, I'll explain. So once you do this, so you might find this, it reveals that basically we can note that there is a decrease in the overall chi-square. From earlier it is 69.693.0849. Then once you have add this model to, it will become 596 to 596.124. And also there is a decrease in root mean square error variant variable parameter as well. It comes from 0.08 to 0.07. And you see that there is an increase of the CFI value from 848 to 878. I think it has come near to the second one. But you can see that even after testing the model 2, assessing the pre-specified model, though there is improvement exhibited, it is customary when using a univariate approach to determine what is the difference between these two models, whether these two models are statistically significant or not. So how you can check this, whether these two are statistically significant or not? You can compare this chi-square value of model 2 and the model 1, and you found that there is a 97.72%, sorry, 72.5 point difference would emerge. Looking at the MIs for model 2, we can observe that the error covariance related to item 1 and item 2 remain a strongly pre-specified, misspecified parameter. So for example, earlier we found there are 4 issues, right? At a time in the model 2, we only address the issue with the item number 6 to item number 16. But we have not addressed the other problem covariance, error covariance with the item number 1 and item number 2. In this case, you can actually do the second model, third model, because this error covariance between item number 6 and 16, the one between item 1 and 2, suggests that there is a redundancy due to the content overlap. Again, item number 1 asks if the respondent feels emotionally drained from his or her work, whereas the item number 2 asks if the respondent feels used up at the end of the workday. Clearly, there appears to be an overlap of this content by looking at the item number 1 and item number 2. Then you need to use this error variances in the model 3. Once again, apart from this covariance between error 6 and 16, and you can draw between these two. I think there is a eureka moment for me now. I think I can draw now. What I'm trying to do is I'm trying to draw here. I think I'm trying, I should draw this. Yeah, thank you. By looking at the picture, I understood. So this is the item 2. So when I did this, see the model has run. Now I can go back and check this model to output view text. See earlier, this is what the value I'm talking about, 693 to it has come 596. And also you can see the CFI value has increased this, right? Now after this, looking at the model 2, again we are not satisfied with the model because we understood still even after running this, it has not gone up more than 0.9. Then again you go back to this and try to add the error variances between these two, item number 1 and item number 2, all right, as the model specified in this, all right. So this is called the model 3. So again you can go back and check how the model 3 results. So let us go here and once again calculate our estimates. Our estimates are being calculated here. Then now I can go back and check the view text. So here see, again there is a decrease 0.519 from the earlier model. And also I can see this model fit. And now CFI has come slightly above 0.90. All right. So unless you satisfied with all those things, right, between your NFI, RFI, TLI, and RMR value, you keep running the models looking at this modification indices, right? So based on this paper, if you can see, as I given the references, I request all of you to just to read once again the paper after this class. The final model is this, because the model 4 after adding this, because this particular item 12 still remaining as a problematic item. So this particular item has drawn to the emotional exhaustion. So initially we thought 9 items to the emotional exhaustion, but in the model 4, when the original authors have tried with taking this particular item to the emotional exhaustion, I think there was a perfect model emerged. Right? So this is what the basic way of doing structural equation modeling. And once you are done with all those model specification, once you are happy, meaning based on the parameters, if you had the values fit indices more than 0.9 and there is no other error variances, then you can think about writing a report. So when you write reporting, what are the best practices for reporting? So there is one way that we can actually understand: read multiple research articles published in a reputed journals like APA journals and other Q1 journals in any subject area, because they practice certain standards, right? Not like very low standard journals. But what is that a reviewer or anybody expect you to write in this? One thing is sample information. When we are actually dealing with the structural equation modeling writing, you need to describe the characteristics of your sample more appropriately and elaborately. Meaning, what is your total sample size? How was the sample size was determined? So what is the demographic info, where they have come from? Like, where is your sample size? Like, which state, which university, which country, and are there any missing data possible? If are there missing data, how did you handle those missing data? And is there any sample random, or any is there any representative of the population? So when you are talking about demographic characteristics, or when you're writing descriptive statistics, I think this is the best way to give the actual and accurate information about the sample. And then once you describe sample elaboratively, then you can also give information about the descriptive statistics. You need to report mean values, standard deviation, skewness, and kurtosis values for all the measures, because these are all very important for us to understand whether there is any univariate or multivariate non-normality data is there. And also you need to report a correlation matrix before you actually do the structural equation modeling. You should make sure that there is a correlations exist between all those items, because at the end of the day, all these items, irrespective of their dimensions, are they measuring the single construct called burnout, right? So you should report those correlation matrix. And other best practices, make data available, which means that open science framework, OSF. All right. Imagine today I'm teaching this particular data. This is not my data. Like, imagine the authors have not kept this openly, all right, for us to test it. Even I will be unable to teach today. So it is always good, like, the people would appreciate. Only thing is, whenever you take somebody's data, make sure that you give their the due credit to them wherever possible. Like, it is always good, like, when you publish an article, people coming, go back and checking and running the same thing and finding out the same values. See, that increases the value, the scientific validity, which means anybody can come and check and find the same values. How do I feel when I actually doing this, finding the same values exactly as the author written, right? I felt so good, right? So make sure that is not that you just do it and discard your data. So make sure that the data makes available through open science framework. And also the model specification. So when you are talking about model specification, always specify your model in three ways. One thing is, in the name of hypothesization, you give a verbal description. How do you hypothesize it? Remember, in the beginning, I have, based on the what is authors, we have given three purposes, three or four purposes, right? Which means that these are the way that how the authors have specified. This is what the verbal description or a specification of your model. And also the graphical specification. All those four models, you can see that original paper, you can understand how beautifully the authors have mentioned. I think one of the best standard article for anybody to read if you wanted to, publish using structure.
Dear participants, kindly remain online. Yes. Thank you, sir. So you're muted right now. We cannot hear you as you are not mute. Sorry, sir. Are you able to hear me? But you need to put your speaker on. You're not able to. Okay. Let me check. How about now, sir?
Yeah,
Yes.
yeah. Because I was put on mute, ma'am. Yeah. Thank you. I think how long I have left from the meeting. I didn't realize. 2 minutes, 3 minutes,
No, not at all, sir. It was just for 10 seconds.
10 seconds, right? Okay. So I hope I'm talking about this particular slide, right? So other than this giving, specifying the model, you can also explain why sum is necessary, right? Because there are other options available. Unless you have a specific reason to do sum, then your data demands or your hypothesis demands there is not necessary for you to do sum. And for models with latent variables, be sure to define the constructs very much clear in your research article. So that's how people get to know what exactly you are talking about it, because construct validity, when people trying to do that, it is mandatory. And also, it is best to verify the psychometric properties of all measures before conducting a large sample sum type study. Meaning, if you are using for any convergent validity and discriminant validity type, you have to check whether all the measures are reliable. Do they correlate with other indicators of a shared latent variables? So you need to mention all those information, and also you need to state the clear rationale for the directionality of the specification. The moment when I say item number 12 to emotional exhaustion, or item number 6 to personal accomplishment, I need to clearly have a rationale. Why am I bringing this particular item to, or having this particular directionality of specification? So which meaning, when I'm say there is a latent variables to manifest variable, I need to say this reflective as well as the formative nature. And you also need to check the regression coefficients, right? And also state the rationale for correlated residuals. Were they specified as a priori or a post hoc, like post hoc? Remember, I think when I run the first model, there is an issue with the item number 6 to 16 and item number 1 and 2. When I mentioned these values, because this was not a priori, it was after finding it, after the post hoc analysis only, I came to know that. So that is the reason why I have done the model 2. So you need to state all those reasons, provide a complete diagram of your model, including all error terms, make sure that the model is consistent with your verbal description. Also discuss theoretically what are the plausible alternatives. Why do you think a particular item 16 is falling in both emotional exhaustion and personal accomplishment? If you think that still that item is problematic even after doing model 2, model 3, better you can discard the item, meaning remove it, or if you have time to recollect the data, modify the item and recollect it. Finally, discuss the plan for model testing, how you wanted to do it, and also estimate, like state which some software package was used. Now you can use Lizrel, M plus, Amos, right? And you can also use R package, and make sure that you include version info. When I said I'm using Amos 31, it is good to mention that, right? And if there is a script or a syntax is available, if you wanted to go with the open science framework, you can put it in appendix, or you can upload in open science framework. As I mentioned earlier, people come and check the data and learn. And specify the estimation method. So mostly we use, when the data is having a continuous data, like at scale type and other things, we go with the maximum likelihood unless there is an ordinal variable or categorical variable. and the state whether the estimation converged and whether the solution is admissible or not admissible. If not admissible, what did you do? Like, were you able to, find the model fit even after doing model 2, model 3? And if alternative models are compared, likewise what we did in the model 1 and model 2, then you need to state the decision rules in advance. You used to select one model over the another, which model you are, agreeing upon. When the testing the full models, establish that the measurement model is consistent with the data before estimating the structural model, because there is a two steps model, the way we did it. And also explain the theoretical basis for respecifying the model. If I am taking one item to another latent factor, you have to tell that because of this modification index was too high, like what we found is not an that's not the acceptable option, because this is the high I'm putting it, because you need to clearly say that verbally, because this particular item with redundant with the other item, so other item I kept it in other model theoretically. So likewise you have to mention, you need to clearly distinguish between the components of the model that were planned a priori from those that were added at the post hoc level. And the communication, under the communication you are supposed to report all the parameter estimates from the best fitting models. You need to report the chi-square, degrees of freedom, probability values, and other fit indices like CFI, RMCA, SRMR for all the models, and report information for an outcome variable, such as R squared value should be given. And you are also supposed to report the residual errors either in the matrix or the lodges. Sometimes if you have a lodger data, you can give as an appendix for people to go through it. And there are common problems with the SEM. After reporting all those things, also your editor would say several things, because when you say what are the limitations about this data, there are common problems. The first thing is generalizability, because generalizability may be limited due to the sampling and the selection of not only subjects, as I mentioned earlier, is also measurement invariance or the measurement effects or method effects. Like, how did you collect the data? You're saying, naysaying, and social desirability, all other things also because of those things, and there will be a generalizable issue. You have to clearly mention it. And also the confirmation bias, because equivalent models or slightly modified models account for 50% of the some examples. There was a study that they found that when they did it, people wanted to confirm their model. So that's the reason, out of 100 articles which are published, and as per the McCallum author, he says that there are slightly modified models publishes in the industry almost 50%, right? Which means that author had certain confirmation bias, because I need to prove my point, right? It is not you are proving your point, but it is actually testing your hypothesized model, that you need to bear in your mind. And also time and causality. Over reliance on cross-sectional designs is not good. Even some can be done using the longitudinal research designs. There are a number of papers, publishing using SEM on longitudinal designs rather than just cross-sectional designs. But you see, 90% of the data, like SEM articles published using on cross-sectional designs, and insufficient sample size. As I mentioned earlier, if you wanted to use a proper this one ADF estimator and other things, we need to have a more data. It is always good, the more the data, the better the results. I think as for the some researchers, the data which are more than 1,000 would be very good. And interpretation, model may fit, but parameters may be weak. At the time, at the end, you see some papers, you read it, you say that you have zero point 0.9, which means I have attained my model fit, but inside the parameters can be weak, several other parameters. These are the some of the common problems when you are actually doing some analysis. And with this, I have completed. Thank you so much for all your support and listening. And these are my references. If somebody wants to learn structural equation modeling, I will learn on my own. All right. These are the materials I repeatedly go through. And there was a fantastic book by Byrne, and other book by Hare, and another book recently by Line. And you also have other papers like these are the 6 books. There are n number of books. I think for beginners, I think if you wanted to learn and master the structural equation modeling, you can choose any 2 books from this, or 2 to 3 books. You will learn structural equation model. Thank you so much.
So there are some queries in the chat box if you could look into.
Yeah. Yeah, ma'am. Let me
The
check.
sharing had
Yeah.
stopped. You could not see the book names.
Sorry, Ranjini Singh is saying, sir, you were suggesting some paper to read before connectivity was lost to someone. Can you please tell which article or paper? Yeah, ma'am. 1 second. I'll show you this. You can take a screenshot of this. The whole data which I used today from this particular paper. Yeah. Testing for the factorial validity, replication, and invariance of measuring instrument, a paradigmatic application based on the Matchlock-Burnett inventory, which was published in 94. This is commercialized, this particular tool. You can use.
Can you,
sorry, ma'am?
Can you reshare? Can you reshare the screen? It's
I have
not
not.
visible.
I have not reshared. Sorry, I thought I'm sharing it. Okay. Ma'am, sharing is not turned on, ma'am. Can you? I sent a request.
Ma'am, sir is not a co-host as of now. That's why.
Okay.
Sir, you can
Okay,
share.
one second. I'll just copy paste and I'll put it in the chat box.
Okay, okay. So,
right. This is the paper. Quickly copy paste and you can read it. Yeah. So this is the paper which I'm talking about it. Yeah. Books names as well. Yes, of course. Sir, please clarify the prerequisite favorable tools and positive results for the better CFA and output. Sir, you can, I've shared the data yesterday and today also MBI data. Start learning from the doing with the exploratory factor analysis, right? Before you actually start doing the CFA measurement model. And also based on this, latent factors, you also try doing the path analysis, all right? So then you do with the CFA. But I'll tell you, there are people who find it other softwares are good, but I find it, even I learned little bit of R, but I find doing SEM is easier in the AMOS. If you're someone who are good at writing coding, I think R is a good platform, but otherwise AMOS is a good platform. Only thing I suggest all of you, you keep doing it. When you keep doing it only, you will master. Otherwise, whatever you learn today, after few days you will forget, right? Sir, if you have to study property technology and tenant experience in India, is SAM good to do? Yes, sir. Based on just 2 variables, I cannot tell you. But actually, if you had any theoretical, you need to understand when you wanted to do this SEM analysis, you need to have the theoretical application, like theoretical framework. Exactly, right? So when you have this theoretical, notion, like what have a very correlation with other things, then only we can say. If you have any idea, please feel free to contact me. And over the phone, I can guide you if you have any specific doubt. But just looking at the 2 things, it may not be good to tell you whether it is good to go or not. Rajini Singh, ma'am. Yeah. Thank you, ma'am.
Okay.
Yeah.
Any other queries from the participants? Okay. So we shall conclude that. Okay. Yes. All the thanks are coming in, sir.
Thank you all.
Good evening, dear participants. On behalf of the Department of Professional Accounting and Finance at Krishna Jayanti University, I really want to extend a heartfelt thanks to Dr. Ramesh Babu from the Psychology Department of Central University of Karnataka for the invaluable contribution that you have done in this faculty development program in the last 4 days. The sessions were really, really enlightening, sir. And the way you have equipped us all into this skill will be visible in our future research works. So the session, whether it was on AMOS, SEM, CFA, or the structural modeling, everything was so simple and very clear in understanding. The way you explained and the engaging manner in which you presented, that was really enjoyable and enlightening for all of us. So undoubtedly, you have inspired all our scholarly works to be done in the near future. Thank you so much, sir, for your expertise, time, as well as the enthusiasm. We are really grateful for your support. Thank you, and we look forward for all the future collaborations with you also.
Thank you. Thank you.